something between 0 and 1. It's always in between that range. So whatever it is, it's between 0 and 1 because this is a decimal form of a percentage, right? So if that x was 98.2, then this would be 0.982.
Oh, I get you.
The 1 represents the 100 in decimal.
Yes, that's right.
So the one that, like, you can see that has more, you just use the other one, you minus 1.
Okay.
The one that gonna have less.
Yeah.
Okay, I think that covers
Let's actually do
isotope
this.
and average mass.
Can we actually do this, please, though?
Oh my god. Come on.
Mr.
You're killing me.
Sam,
Yeah.
you do this.
You distribute the 14.001.
Yeah, okay. Let's do it. Alright, fine. 12.00x plus 14.011 minus 14.0001x. Oh my god, you can combine these x's, can't you? I think you can. And you can take this 14.011 and subtract it from this side, right? You can do all that stuff. It's good clean algebra. I love algebra.
And if you like subtract these two numbers, the x's and x's, do you use the same subtraction?
Do you use that? Yes, you could still use that, but they should turn out just perfectly like they are right now. So let's try it. So let's do 12.00 minus that. It's going to be, what is it going to be?
Negative 1.99.
Yes, 1.99.
Yep, with 0, I guess. Because it just says negative 1.99.
Negative 1.990. Okay.
Yeah.
There we go. That's x, and that's going to be plus 14.001. Now what do we do? Oh my god, we now subtract this on both sides.
That's the wrong thing. Sorry. Negative 1.990 is 12.0111 minus 14.0.
Oh my god.
Okay, sorry.
12.000 minus 14.001. That's what I need.
What is that? That's negative.
Should be negative this.
Oh.
Is that
Negative
nice?
2.0.
Okay, that's right. I got him. I'm in mistake. There. All right.
I don't get what's going on.
It's okay. You got time. Now you subtract 14.001 from this 12.011 on this side, and you get.
That equals
That equals 2x, and then you divide by negative 2.0.
And you divide both sides by
So
negative
you get your answer.
Yes. Okay. I think you could do the rest.
Whoa.
You can do the rest.
Okay.
Mr. Sam, where did the 14.001 go?
Oh my god! I subtracted it. Come on, pay attention here.
Where did you subtract
I
it?
just smacked.
12.00x minus 14.001x.
Yeah, exactly. So are you going to pull that 14 over on the other side?
Eventually, yes. I decided just to quit at that point because you guys can see where it's going. Okay, we distributed it. We combined like terms.
Also that
We're good.
1, that x minus 1, whether you count that 1 as a sig fig or not.
No.
Okay.
All right. We're 30 minutes in. We got to get going. The next topic is alpha, beta, gamma. It's not a fraternity or a sorority. It is radiation. It's totally radiation. You got it? Let's do it. Okay. So let's focus a little bit. Right now we need to, I would rather not have to repeat this over and over again. Okay, so alpha. What is alpha? Alpha is, it's a particle coming out of the nucleus. It's the weakest, right? So you've got a nucleus. Let's say you've got a nucleus like this. It's got 4 protons. It's got 1, 2, 3, 4, 5 neutrons. That makes it boron. It's got 1, 2, 3, 4 electrons. I'm just drawing this like crazy, right? Let's just say it. This is how it is. I know this is not any model that we're used to. In fact, let's just change this a little bit. Let's do this just to make it a little bit easier for you guys. Okay. That's the Bohr model. Right? We got different shells. Hold on. Let me just explain it first. Okay. Now we've got protons, we've got neutrons in the middle. Let's say that, and we can write this element out like this. We can say this is boron. It's got 5 neutrons. It's got 4 protons. So 4 protons, and overall it's got 9 as its mass. Right? Right. Now we can draw this with alpha decay. Okay. Now this thing is gonna spit out an alpha particle. Right? This is how we draw an alpha particle. 2 He, and it's got helium. 4. What's the remaining atom? Now you look at this and you say, okay, well, this right here, these two sides should equal each other, right?
Where's the thing?
So this needs to be 2, and that needs to be 5. So it turns out that helium is left over after helium leaves. That's kind of weird, but it's true. That's how it works right here. In this particular case, this is an alpha particle being shot out of the nucleus. Okay? It'll come from the nucleus, so the remaining helium is going to look like this. I'm just now going to draw the remaining helium after the alpha particle has left. Here it goes. I'm just taking away the alpha particle. Ready? Ah! Okay, there it is. The alpha particle's gone. That's it. Okay, that's alpha. Alpha is the lowest amount of energy that's given off. Let's talk about beta. Yes.
Do you have to know the pictures?
Do you need a what?
No, the pictures, the
The pictures. This picture?
yeah, like, do you have to know what it
Do you not know what it means? Those are protons, those are neutrons, those are electrons.
like how many?
Come on, you can do that.
Okay.
I know you can.
Like
Alpha is weak because it's stopped by paper, air, whatever. It's very weak. You know that. Beta, yes. So beta is, alpha is stopped by paper, air, very weak sort of particle. Those are the two things that you could possibly have on a test. Now, beta, stuff like aluminum, right? Metal. I'm not going to throw a trick question about this in the test. Don't worry. If I say what is stopped by aluminum that has also got a negative charge, you'd say, oh, that's beta. I know that, and you can choose that from a list.
So that's definitely happening.
I'm not saying it is. I'm just saying.
About alpha. What would be the question?
I'd ask a question like this: what would happen if an alpha particle shot out of an atom like that? And you'd say, oh, well, I'd ask you what particle's left over, or finish the equation here. And you guys can do that. You know that alpha is that helium. Okay? Yes, still the periodic table. Now, let's start back over here again. We've got this. There it is. We got our boron back here. I think it's a boron. Yep, it's a boron. We got boron, and now let's say instead of alpha being shot out of this, let's say now all the tables have turned. We've got a beta particle, and it's not just any beta particle, it's the negative beta particle, so it's an electron being shot out. Whoa, that's weird. So what's being shot out of this atom? What would you write?
3 electrons.
1 electron's being shot out. So you write it like this. And then what's remaining over here? 5, that's right. 5 on top. So this would be, wait, I wrote that wrong, didn't I? This should be 9.
So that's 9.
That's 9. And this is 9. 9. And then we've got, what element is this with 5 protons?
That's boron.
Oh, I'm sorry, I wrote that wrong before. So I'm not completely confused, you guys. This element right here with 4 protons should have been beryllium. It's been a long break for me. I know. So before that, when we had the beryllium, we had the boron before, it should have been beryllium. Sorry. I just didn't see which element it was. You guys can look it up in the periodic table. The fourth element is beryllium. This element right here is boron now, since it's got 5 protons. Okay? This is beta decay. That's what I can ask you on the test. Thanks for raising your hand.
It doesn't matter whether or not it's alpha, beta, or gamma. Like we can always do the same process for each of these equations, right?
Right. The tricky part though is if I just stipulate, I say, okay, start off with this and tell me what's the result when there's a beta decay. Okay? What's the result when there's a beta decay? That part is a little bit tricky because you need to know in that section what a beta decay particle looks like in an equation. You need to know that it's going to be like this. And so then you also need to know that it's going to be like this.
And what is it?
What is that?
That's a B.
But a beta can be
Is beta like 1?
A beta can also be positive, so I make it very clear which one it is. It's either positive or negative. If this was positive, and in general we don't need to know this, that was positive, what would this be now?
That would be 4.
That would
No, 3.
mean 3, and that would be lithium. Right?
Wait,
Yeah.
so it means that you're adding the electron when it's positive and
In this case, you're shooting out a positron.
oh, okay.
That's a 3 right there. And in the other case, you're shooting out an electron.
Oh, I got you.
Okay. The final one's the easiest. That's a gamma. So what would this equation look like if we are shooting out a gamma?
Is it just nothing?
This. And it's just like this. Okay, that's it. The most energetic is the gamma.
So wait, gamma, nothing happens.
Gamma, nothing happens to this atom. You just have, what's really going on there is the protons and neutrons are shifting. They shift in such a way that it just gives off energy, does not give off any mass. Okay, so in that case, we're not going to be showing any mass given off right there.
So it stays okay.
So it stays the same.
So it just lets off energy.
Yeah, and that energy is so strong that it can go through just about anything, and lead is the thing that can stop it. And it has to be a thick piece of lead too. Yeah, that's easy.
So for alpha, it's helium.
Yes.
Like instead of the E -1.
Yes.
And then this is just gamma. Then the beta is E -1, and the alpha is helium. So it's 2. No, it's 4 and 2.
So it's yes.
4 on the top and 2.
Alright,
Yes.
so basically,
Good.
gammas let off gamma rays, that's it. Which
Yeah.
are just energy.
Well, can we count like what would happen if gamma?
That's it right there. This is what would happen.
I thought that would be.
This is gamma. Come on.
Wait, is that like a number then?
This is like American
It's nothing.
time or
Oh,
something.
we just write a sign.
Oh, Don, I'm so happy you're here. You're making it lively and entertaining. Otherwise, it might just, yeah. So
The video recording.
those are recording, or those are all recorded. You can go back and look at it. Don't worry. Okay, if something wasn't quite clear, take a look at it. Tomorrow we're going to go over this again in class. So if you have any questions, if something's like eating at you overnight, you can't get to sleep because you, oh my God, I forgot what an electron would be like decaying from beta decay. Oh my God. If that keeps eating at you all night, don't worry. We've got lots of resources. You can look at your workbook. You can look at your quizzes. You can come into class tomorrow and say, oh my God, Mr. Sam, let's talk about beta decay. And I say, okay, fine, we'll talk about that today. And we will, all right? So don't freak out right now. Freak out tomorrow. Okay, next thing we need to do is we need to talk about fusion and fission.
Do we need to just like know like the formulas or
That's what I'm going to talk about. What do we need to know?
do we need to know like, that's what they do as well?
I'm going to tell you.
Alright, okay.
You can keep guessing if you want to.
Yeah,
Okay.
okay, now.
Okay, never mind. Now, fission is when you have one atom and it divides into two. So fission is division.
Chain reaction.
Fusion is a union of two or more atoms into one.